Today we'll be starting the lecture series for examination point of view, and today the first topic of our lecture is alcohol, which is an inebriant, and it is a clear colorless liquid with a typical fruity odor having a burning taste. Ethanol is both water and lipid soluble. Now, hydroxyl and ethyl moieties confer both hydrophilic and lipophilic properties. Thus, ethanol is an amphophile. Now, we should know the exact percentage of the different beverages that contain the amount of alcohol. Like beer contains only 2 to 6% of the ethanol, cider contains 4 to 8%, champagne has a 12% quantity. Wine is again an organic product and which is made through the process of fermentation, and it contains about 8 to 20%. Then come the alcohol products that are made by fractional distillation. In that, tequila contains 40% ethanol, gin contains like about 40 to 47%, whiskey contains 40 to 50%, vodka again 40 to 50%, rum 40 to 60%, and brandy 40 to 60%. And then there is the country liquor or the moonshine whiskey, which it has a wide range. It depends upon how is it made, by which product it is produced, and by which method it is made. Either it is fermentation or distillation, whatever the process. Like they even use the car radiators for the distillation process, and that equipment causes a lot of lead poisoning too, and it contains about 15 to 60% of the ethanol. Then the question comes that how much of a beer is equivalent to how much of a vodka or tequila. Now, about 355 ml of a can of beer is equivalent to about 250 ml of malt liquor, and it is equivalent to like about 150 ml of table wine, which is equivalent only to 40 to 44 ml of 40 to 50% is whiskey, ethanol, and either gin or vodka or tequila. So this comparison is important when we have to calculate the blood alcohol concentration when a person gives a history that he had only a couple of beers. So a couple of beers are equal to a couple of shots of 44 ml of gin, tequila, vodka, or whiskey. Now, how is alcohol or ethanol absorbed? The physiochemical properties of ethanol are such that it is slightly polar and has a weak electronic charge and a low molecular weight. This makes ethanol miscible in water as well as in lipid. So it can cross the blood-brain barrier as it is lipophilic, and it is also miscible in water content, and thus it goes into the every compartment of the body. It is easily absorbed and passes through the cell membranes by simple diffusion. The most common route of exposure to ethanol is ingestion, but it can also be absorbed by inhalation of the vaporized ethanol or through even skin. Ethanol absorption after ingestion begins in stomach, and only a small percentage of it is ingested in stomach. However, the most of the absorption takes place in the small intestine, which is about 80%. Then factors that delay or enhance the gastric emptying will influence the rate of absorption of alcohol, like food. Presence of food in the stomach prolongs the absorption of alcohol. Presence of starch, protein, fatty food retards the absorption. It is stated that with the presence of food in the stomach, as much as 17 to 20% of the alcohol ingested escapes absorption, and it never appears in the blood. So if you are taking alcohol on a full stomach, 20% of the ethanol is just there, like you have wasted it. And then the concentration, the diluted alcohol or the alcohol with high concentration are absorbed slowly, whereas alcohol in concentration of 10 to 20% are absorbed rapidly. Habit and tolerance: in habituated persons, alcohol is absorbed rapidly. Drugs may interfere with the absorption, and finally, gastrectomy may cause rapid absorption of alcohol. Then distribution, as we have already discussed, that being lipophilic and water soluble, it just crosses every compartment. It is equally distributed in every compartment of the body, either the water soluble compartments or the blood brain barrier, like the lipophilic barrier of the brain. It even crosses that. So the distribution ratio between alveolar air and blood is 1 is to 2100,